Okay, hello everybody, and welcome to this tutorial about programming using the LEGO Mindstorm platform. What we're going to do in our career study for mechatronic engineering is develop a robot that automatically has to follow a line and keep the track until it reaches the end of the full circuit. Now the idea is to do this in the less amount of time possible. So programming the robot is essential and very important for it to work effectively. Now we're going to start using the LEGO Mindstorm platform. You can go to the Start menu and look for LEGO Mindstorms, and you will open the program, and this is going to be your first screen, where we are going to create 3 new programs, and we are just going to evolve and show different types of tools that this software has. Now the first one, we can call it tutorial 1. Click on go, and we will have our first tutorial. Now we can develop a set of different programs for this tutorial. We have tutorial 2, and the last one is going to be tutorial 3. After you have created your 3 programs, we're going to start our learning in tutorial 1. As you can see, the LEGO software has all the tools on the left side. These are the most common tools and the basic structures for creating the program. Now this uses block diagram programming. Now block diagram programming is very similar to code, just that all the different elements, like the methods and the behavior of the objects that we are going to use, are already there for you to change and to establish different parameters. Okay, so the very first tool that we're going to use is called Move. You're going to click on Move. Now you see all these gears. Now this will be put in the set or in the process of the program. Now we're going to leave it here, and this is going to be in the process. This means that this is where the program is going to start. It will start with the movement. Now if I click on this block, on the bottom part, I am going to see a set of parameters that this has. So the first parameters that we're going to look at is our ports. Now the ports is where you connect your motors. This is the block diagram, or the block symbol for the motors. Now if you connect, there are 3 ports, A, B, and C. B and C means that you're connecting 2 different motors. You can also connect 1 motor. Okay? Now you can connect 2 motors, and this movement will be synchronized. So it's very simple. You select B and C if you have your motors connected to the B and C port. The direction can be forward, backward, or stop. In this selection, when you have 2 motors, if you select forward, both motors are going to go in the same direction. Also depending on the way you assembled the robot. If you choose backward, it will go backward, and then stop, both motors will stop. So let's say that we are going to ask them to go forward. The third parameter is the steering. Even though you can ask the robot to go forward, you can set a slight turn. So in this case, if you select the steering of B and C, you will have a slight turn of the motors. This is reflected in the speed of each of the motors. One will go faster, one will go slower, and that's how it will turn. If you leave it right in the middle, both motors will have exactly the same power. Now the fourth parameter is the power of each of the motors. Now it's in a range from 0 to 100%, and you will notice that the faster you go, the less effective the sensors will be, and it will be harder to control your robot. So this is an extremely important parameter to start looking at when you are tweaking your robot in order to make it faster. The fifth parameter is the duration. You can make a duration in rotations, degrees, seconds, or you can have your robot go and do this unlimited. If you would like to do it for a certain amount of time and make the robot go forward for, let's say, 5 seconds, you can select it from the drop-down menu. Now, what will be the next action after this block is continued? Our sixth parameter talks about the break, or if it needs to continue doing the same thing. So let's choose break, so when it finishes, it will stop. So at this point, the program will start. The two motors, or the robot, will go forward. The two motors will go forward for 5 seconds, and then they will stop. If I want the robot to go forward for a certain amount of time or a certain distance, then I can choose rotations. Now, I would have to do a little bit of calculations to see what is the exact diameter of my wheels in order to get the certain amount of rotations for a certain length. If you say 5 rotations, you would need to translate this into length. So let's say we want our robot to go straight for 10 seconds, turn 360 degrees, and then go back to the starting point. Since the robot does not know how much is 360 degrees, we would need to translate this into seconds. How much time does it take to turn 180 degrees and go back? So we need to translate this movement. So let's say that we're going to start a robot. He's going to move forward 10 seconds. Then he's going to stop. Okay? Then, as soon as he stops, he's going to change his direction. So in this case, I'm going to continue doing B and C. Like, I have the same motors, remember? Always check that you have the same ports. In this case, I'm going to make it steer completely. Like, put it all the way to the right. So he's going to steer completely. So in this case, one motor is going to continue and the other one is going to stop completely. And I'm going to select 10 rotations of that motor, and then of course it's going to stop. After it stops, it has to go back. So when it goes back, then the robot should go forward again for the same amount of time that he did it in the beginning, for 10 seconds, and then stop. So this is the basic movements of the robot: moving forward, backward, turning right or left, turning and steering. Now let's go to tutorial 2. In this case, our robot will need to wait for a response. First of all, we're going to look at the tool called wait, and we can select, there are many parameters to wait for. You can wait a certain time. You can wait for the touch of a button or an electromagnetic sensor. You can wait for a light range. If there's light, you can wait for sound. So the robot, what it's going to do is it's going to halt until one of these things happen. If you have a distance sensor and if you have the color sensor. So here you have the different types of sensors: light, electromechanical sensors, the sound sensor, the distance sensor, which is an ultrasound sensor, and the color sensor, which also works as an infrared sensor. So let's say that our robot, before it starts, is going to wait for 1 second. Then after the second, he's going to start doing the process. Now in this case, he's going to move for 15 seconds. Okay. Then he's going to stop and wait for another second. Now these wait parameters mean that the robot is not going to do anything. The robot at this point during that second is completely blind. When we put our sensors back and when we start using sensors, those delays and those wait blocks shouldn't be used, because during that time that he is in standby mode, he is not detecting anything from the exterior. For this purpose, in order to learn how to program, we're just using the delay because we're not using any sensors yet. So he's going to wait for a second, go ahead for 15 seconds, stop and wait another second, and then turn. Now in this case, I'm not going to steer. I am going to turn my robot in its own axis. Now the turning will be a lot more, will be faster, because it's going to do it in its own axis. Okay? In this case, I need one motor to go forward and the other motor to go backward. For this, I would need 2 blocks. This one, and I'll select B only, and I'll ask B to go forward for 2 seconds. And I'm going to ask the next robot, the next step, or the motor C, to go backwards for 2 seconds. Don't worry that they're in separate diagrams. The program or the computer does this in microseconds. So you won't notice when he does this and starts this and right away starts this. Okay? He will do it immediately. So he's going to do it for 2 seconds and then do this for 2 seconds. In this case, the robot will turn on this motor for 2 seconds, and then after that instruction will do this in the other 2 seconds. If we want the next action to be exactly the same time and do this and immediately do this, well, we should select coast, like go ahead and do the other one. Okay? In that case, they will do it at the same time. Now when we're done and when we have turned around, then the robot can do the last movement, which is go back straight for 15 seconds. After this is done, the robot can actually, and let's say I want to do this a number of times. I don't want this to stop here. Well, there is a tool called looping. Loop-in programming can be developed in 2 different ways. One is a for loop, where you establish an index-based number of times that the process is going to be held. And the other one is a while condition, that it will exit the loop until something happens. In this case, the loop that we have over here will tell us do it an infinite amount of times. Now everything that goes in the loop is what is repeated an infinite amount of time. So we need to put our stuff inside the loop in order to work. So he will do this an infinite amount of times. Now the parameters of loops are in the bottom. If you select the loop from here, you can say control it forever, control it by a sensor, control it by a time, control it by a count, or control it by logic. Like this can be done if we want that this is done until, let's say, I yell at the robot. Then I'm going to choose a sensor that says sound sensor, and the criteria in order for this to stop is when the sound is activated. Now the sound sensor has different parameters, such as the port, which is very important, and the sound intensity. So you can say when the sound is greater than 50, which is probably, this is just a number, it's a ratio between 0 and 100. It's not it's not measured in decibels or anything like that. We just have 50% of the sensor's capacity. That's what it's saying. That when it reaches more than 50% of the sensor's capacity, it will do this. So this loop will tell us how to do that. If we want to do it forever, or by time, we want this loop to continue for, let's say, 30 minutes, or just count the amount of times that he's doing it. Or, logically, if something is true or false, it would go out. Now, in our third program, we are going to combine different aspects of looping plus a new tool called switch. For the robot that we are building, we need the robot to continuously go around the track forever and move forever. So we're going to need a loop. We're going to need an infinite loop. This infinite loop will have a motion and a sensor. In this case, we need the robot to do something else when he doesn't detect the line. So we're going to use a function called switch that will allow us to choose when something happens and doesn't. This switch tool has some parameters, and is that we can choose the type of sensor. So we can choose a light sensor, or we can use a color sensor. If we use the color sensor, we can establish the parameters on the compare section. Now we select the port where we should connect our sensor. You can select the port. Make sure that this port corresponds to the one physically on the robot. It is important that you know that. Now the compare can be inside, or if you click here, you can see outside. Now the check mark means that if it's outside this range, it will develop this process. If you click on inside, it means that if it's inside this range, it will develop the process. And this is the case when that doesn't happen. So for our robot, if it's outside the black range, we're going to establish this process. And if it's not outside of the range, then do this. And do that an infinite amount of times. So let's say that if it's outside the black area, it should kind of like turn, because he's not detecting the black mark anymore. So you want it to steer, right? And this steering is up to you. If you want to steer completely, if you want to just steer a little bit, and this will totally affect the way that you move and the fast and the speed that you move with. Now, if this is not happening, if it's not outside of the range, it's because it's in black. If it's not outside of the range, it's because the light sensor is detecting the black color. So he's going straight, or he's on track. And if he's on track, you need it to go straight. Sorry, we need to fix this, yeah. You need it to go straight, and you would like to speed up a little bit. Now he's going to do this a certain amount of times, a lot of times. I'm going to ask you for some other requirements for your robot. Like, you can change the way that this is done. There are infinite ways to program the same thing. And the way that you program it, adding more situations and taking care of all the variables is what makes a good robot. You're going to add some other stuff. Like you can add to this maybe a display. Say, okay, I want this to continue, and before the program actually starts, I just want to put a happy face on the display so it looks happy. Or you can change it from the parameters and say you want these eyes to look on my display. I can also say that my robot needs to wait for sound until he starts doing this. When I say go, the robot will start developing the process. So imagine there are millions and millions and infinite number of ways that you can program the robot in order to be effective. For this assignment, you should hand in the 3 tutorials, plus you can add different things to each of them. Okay? Using different tools of the ones that we saw today. So let's get ready and let's create some really cool robots.